Video 34, Math Lesson 5.3, Part 1, Comparing and Ordering Fractions. Before we start practicing with comparing and ordering fractions, there's something really important to remember when we're talking about fractions. Let's take a look at these two fractions here, 1/6 and 1/8. And the question is, which fraction is larger? Remember, a denominator that is a smaller number is actually going to make a bigger piece of the whole. Because if I have one whole circle, if I divide it up into 6 pieces, each piece will be this big. So 1/6 looks like this yellow section here. If I take that same whole circle and instead divide it up into 8 pieces, it would look like this. Now, my pieces are smaller sized, right? Because I took this whole and I divided it up into more parts. So 1/8 is a smaller piece than 1/6. And it's important to keep that in mind when you're comparing and ordering fractions. So if we were to look at these 3 sets of fractions, our job is to put them in order from least to greatest. Okay, so if we look at our first row here, we've got 1/3, 1/2, and 1/6. Now we can draw a picture of that and we can see that our 1/6 piece is the smallest, our 1/3 piece is the next smallest, and our 1/2 piece is the greatest. Making a picture of your fractions can sometimes help. Not always, but sometimes it's helpful. And let's check our answer. Excellent. 1/6 is the least, 1/3, 1/2 is the greatest. Okay, take a look at the next row, and in your mind right now, think which one's the least, which one goes next, which one's the greatest. Okay, the least is 1/8. Oops, 1/5 is next, and 1/4 is the greatest. We can check our answer to make sure that we did that correctly. Okay, there we go. Take a look at the bottom row and write your answers, or not write it, just think it in your head. Which one is the least? What order would you put them in to go least to greatest? This time we don't have pictures there. Now, if you want to, you could draw pictures. However, I'm wondering if you noticed any type of a pattern. Every one of these fractions is a unit fraction, and what that means is the numerator is 1. So it's just one piece of the whole. And since the numerator is the same for all of them, they're all ones, we can easily compare these fractions by just looking at the denominator. You'll notice here that the denominator with the largest number makes the smallest fraction, 1/6. And the next largest, and the denominator that's actually the lowest number, makes the biggest fraction, because it just means that we're dividing that whole piece into less pieces. You'll notice the same pattern here. 8 is the largest number, so the denominator with the largest number is the smallest, and then you can put them in order this way. So knowing that fact, when you look at these 3 fractions on the bottom, you don't even really need to make pictures. Because the numerators are all the same, we can just compare them by using the denominators. And a larger number in the denominator means a smaller fraction. So we would put them in order like this, from least to greatest. That always works even if your numerator is not 1. As long as the numerator is the same for the fractions that you're comparing, all you got to do is look at the denominator. Now, let's say you're asked to compare fractions through a story problem. Who is closest to completing the charity bike ride? Okay, we've got a 15-mile bike ride for charity. Carmen has completed 2/5 of the ride, Sanjeev has completed 1/3 of the ride, and Nancy has completed 4/15 of the ride. Now, there's many different ways that you can solve this problem. Here's one that I'd like you to consider. You can use either fraction sticks or pictures or even just make a grid like the one you see here to help you compare these fractions. Let's take and fill in 2/5 of these. Now there's 15 total boxes, okay? Because 15 would be the least common denominator between these three fractions that we could have. So if we shade in 2/5, that means we're going to shade in 2 out of every 5 boxes. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. We shaded in 2 out of every 5 boxes. Now let's shade in 1/3 of the ride. So that means we're going to shade in 1 out of every 3. Or another way we could look at it is if we divided this into thirds, like strips. 1 here, 1 here, 1 here. Each strip is a third. We got to do 1/3 would be filling in 1 strip. Okay, so that's what 1/3 of the ride would be. And then 4/15 of the ride, we've got 15 boxes here, so that means we would just complete 4 of them. Okay, so now that we're looking at each of those 3 fractions in the same terms, which one went farther? Which one has the most boxes filled? This has 4/15. This has 5/15, or 5 out of the 15 boxes. This one has 6/15, or 6 out of the 15 boxes. So that means that our first girl here, I can't even remember what her name was, Carmen has completed the most of the ride. Okay, so now we've already talked about several ways that you can compare fractions. Okay, one way we talked about was if the numerator is all the same, we can just look at the denominator and put them in order that way. Another way we talked about is making pictures. You can make a picture, shade them in, and compare that way, or using a grid. And what we really did here too was we used equivalent fractions. We looked at 1/3 as in how many 15ths is 1/3? How many 15ths is 2/5? And when we made equivalent fractions like that and used this picture grid, it helped us solve the problem. Here's another example where we could possibly use a grid or some type of a fraction stick. Which is larger, 5/8 or 3/4? Okay, well, if we have our eighths here and 5 are shaded in, 3/4, we need to color in 3 out of every 4 boxes. That's what 3/4 means. How many eighths is 3/4? 6/8. So 6/8 or 3/4 is larger. And what we did here was we used a common denominator. We used the least common denominator for these two numbers, which was 8. Now, sometimes you can figure out how to compare fractions without making pictures, without drawing grids. There's so many different ways that you can work these problems out. So I'm just trying to point out a few different ways you can think about it. When you did your math message today, it asked you to decide whether measurements were closer to 0, 1/2, or 1. I personally think that that is the very best way for you to start out any type of a comparison problem. A lot of times, just answering those questions will help you and you won't even need to do any more work than that. For example, let's take a look right here. We need to decide if 2/7 is equal to, less than, or greater than 3/5. Now, if I ask myself that question, look at the fraction 2/7. Is 2/7 closer to 0, 1/2, or 1? You might say 0, or you might say 1/2, knowing though that 2/7 is less than 1/2. Now if I ask myself the same question for 3/5, is 3/5 closer to 0, 1/2, or 1? Okay, you probably say it's closer to 1/2, but we also know that it's just a little bit more than 1/2. If 2/7 is less than 1/2 and 3/5 is a little bit more than 1/2, then I know that 2/7 is less than 3/5. Cool, huh? Now, sometimes that question won't be as helpful for you because you look at 7/8 and 3/4. Is 7/8 closer to 0, 1/2, or 1? Yeah, it's closer to 1. Is 3/4 closer to 0, 1/2, or 1? Well, you're probably going to say 1. Each of these are one part away from being a whole. But what do I know about these sizes of pieces? 7/8 is only 1/8 away from being a whole. 3/4 is only 1/4 away from being a whole. But what's a bigger chunk to be missing? A 1/8 size chunk or a 1/4 size chunk? 1/8 is a smaller chunk than 1/4, isn't it? So 7/8 is going to be closer to 1, which means 7/8 is greater than 3/4. Now, another way I could look at this problem here, because my denominators are 8 and 4, I know that I could make an equivalent fraction for 3/4. I could ask myself, well, how many eighths is 3/4? Yeah, it's 6/8. 7/8 is greater than 6/8. Okay, here's another one down here where we have 4/5 and 5/6. Each of these fractions are only one piece away from being a whole. Is a 1/5 piece going to be a bigger chunk missing than a 1/6 piece, or a smaller chunk missing? Yeah, it's going to be a bigger chunk missing. And so that can tell me if that 4/5 is less than 5/6. Now, if that doesn't make sense to you in your head, you can always make equivalent fractions. But I have to find a number that both 5 and 6 are factors of. Can you think of the lowest number that both 5 and 6 are factors of? In other words, what would our least common denominator be? If you said 30, you're absolutely right. So I would need to make equivalent fractions with 30 as a denominator. And we're going to talk more about making equivalent fractions in a couple of days. This is something you've done in the past, but maybe your brain's a little cobwebby on it, and that's okay. So I would make an equivalent fraction. I have to multiply by 6 to get 30, so multiply this by 6. 24 over 30 here, and I'd have to multiply 6 times 5 to get 30, so 5 times 5 is 25. So I have 24 thirtieths, 25 thirtieths. Whoa, they're very close, but 4/5 is less than 5/6. Now this one here, super simpy, it's half. It's half. I can see that. So I'm going to put a half right there.